Alright, so for question E, we need to get the temperature and heat flux at the nodal points, or heat flux at the boundary conditions. So we have here we have, so this is just the MATLAB program. This is just set up, just the values we were given, just setting up nodes, number of nodes, number of elements. So, and then we have this for loop to loop and get k and f. Like no, this this loop right here is to get to pull the value of a, k, and q, and then from that value we can input them into the assign the element of stiffness k, and then from there we assign it to the big matrix, the big K matrix. Same thing for f, and then we print k and f, and then this we need to take out the first row, so it's need to be like from 2 to the end, and that's where we get these from. So this is k, which is the same thing as what we got in D, or like in the hand calculation, so that's pretty good. We have f without the boundary condition, and it's the same, so it's also pretty good. And then these are the things that we need to subtract to get out of the main thing. Then temperature, we need to get temperature, and here's an array for where we need to get those. So here, like, we need to get it at the nodes, and that is where we able to get these. And you can see here, these are the values of the length of the nodes. So we got t for those. That's good. We got the graph. It's like goes from -20 up here because of the positive q, and then it's linearly decreasing because there's no q in the middle two elements, and then it's sharply decreasing because there's a negative q at the last element. For reaction heat flow, so for reaction, and yeah, here we got the reaction. Basically we just pull out the value of k and t and l, and then from those value we place them at the boundary condition, and that's why we were able to get these. So that's pretty good for A. For F, here's the action, here's the stuff. So heat flow, we have here's like what is printed when we input the values. You can see here, like when we input, for example, this value, it says where it's located, so in this case the second element, and then it display the t and q at that x location. Here's the MATLAB for part F. Yes, you can see it's just we add this part and then we input it from the keyboard. This is the published functions, that's why this part is errored, but the result is both. We have random x, so we set this is to determine where x is located, your x, what element, and then we have the temperature and heat flux at that specific element calculating. So that's pretty good for F. A, B, C, D, E, F, G. So this is G. For G, it's pretty much the same. The first part, what we changed for G to get the values is, instead of inputting x, we have an array of the elements of the nodal points that we want, and then as you can see, like, these are what is translated into, and then from 1 to 8 we run n from 1 to 8, basically just to loop it, to run and pull out each of the x element. We get the x out, and then from that x we are able to get we're able to get the um, the location, the temperature there, and the Higgs flux there. So yeah, basically same thing all over again. And here's what displays. So let's say the node here locates where the temperature there, the Higgs flux there. So the first element, this first element. So these are the two at one third and at 3/4. Same thing here. Um, Here's for the second element. Here, second element, third element, and fourth element. So, yep, that's it for G. And H, to answer the question, I think it's pretty easy to find the exact solution by integrating twice and applying the boundary condition because Qx is linear, so the function of x is not too complicated. Tx will have like a parabolic profile, and the FEA solution is not close because it's linear, but I think it can be acceptable because the exact solution will be 2 to the power of 2 will be quadratic. So yeah, that's it I have for this homework.